Okay, hi everyone. This is the homework question from Friday, number 2013, number 4. Okay, so this is the graph of f prime, and that's really important to remember. It's f prime. And we're just talking about going from 0 to 8. And they're talking about horizontal tangents, blah, blah, blah. And they're also telling you that in the original function, f of 8 equals 4. I'm sure that's going to be important at some point. Okay, so part A. We need to find all the values for when f has a local minimum. Okay, so think about this. F has a minimum or a max, right? Has a max or a min. It doesn't matter. We could just consider both. F has a max or a min when f prime equals 0 and there's a sign change. Okay? So when is f prime equal to 0 and also have a sign change? So if you look at, let me get another color. If you look at over here at x equals 1, the slope is equal to 0, but there's no sign change. It did not go through the axes. Over here at x equals 4, there's definitely a sign change there, one from positive to negative, and that's where it's equal to 0. It's f prime is also equal to 0 right here, and there's a sign change. Okay, so how do we decide which is a max and which is a min? So if we look at the one when x equals 4, over here it was f prime was positive, so that means the slope is positive, it's going up, and then it was negative, so it's going down. So there's a max at x equals 4. If you look at where x equals 6, the slope, because this is the derivative graph, is negative, so it's going down first, then it's positive, so there's a min at x equals 6. And this question is asking when is there a min? So there is a min at x equals 6, and that was worth 1 point. Okay, let me erase. Okay, part B. Just get a different color. Okay, part B. Where is there an absolute min from 0 to 8? So an absolute min or an absolute max will occur at critical points or at the endpoints. So our endpoints are 0 to 8. So we need to find f of 0, that's for sure. We need to find f of 8, and then we need to find f of any critical points when there's a min. But we already found the min in part A, and we know that there's a min at 6. So we have to find f of these three numbers. Okay, well, they already told you that f of 8 equals 4, so that one's already done. Okay, so now we need to find f of 0. So what is f of 0? Now you might look at this graph and you say, oh, f of 0 is right up here. But that's wrong, because this is not the graph of f, this is the graph of f prime. So to find our location, and we've talked about this very briefly, and that's why it's so important to watch these videos, you would want to find the distance traveled, or the length, or whatever you want to call it. Sorry, I don't know what just happened here on my graph. Okay. Going from 0 to 0. So 0 to 0 might not make much sense, but let's pretend it was 2. So if I wanted to know like f of 2, I would want to go from 0 to 2, because that would tell me all the space that was enclosed, the accumulation, which would also be, you know, how much I traveled, like where I am, my distance. Okay, so from 0 to 0 is, now normally if it's the same on the bottom or same on the top, if you do the integral, it's always 0. So if you do an integral from 2 to 2 of f of x dx, it's equal to 0, because no space has accumulated. It's just stayed from 2 to 2. Okay, but here is the problem, that you need to know where did you begin. So this is like the question, I don't know, we did questions about like water in a barrel. So if the barrel already started with 50 gallons of water, when you find out how much oil was in there after 3 hours, you have to add the original 50. So we know to go from 0 to 0 is 0, but where were we when we started? So what if we had started at 3? Then the answer would be 3. Okay, so we don't know anything about what happened at 0. So what we actually have to do, and it's quite clever, we do know where we were at 8. Okay, at f of 8, when we were at 8, we're at 4. So when x is 8, we were at 4. So what if instead of going from 0 to 0, what if we start at 8 because we know about 8 and we go to 0? Okay, if we do that, that's going to give us everything all the way from here, from 8, all the way down here to 0. Now you might be saying, but we don't need all that. We're not going to worry about that right now, okay? Okay, so at f of 8, it was at 4. So we have to add 4 to whatever we get. Okay, so now we run into another problem. We can't have the bigger number as the bottom limit. It always has to be on the top. So there's a rule that says that you're allowed to switch it. We can switch it and put the 8 on top and the 0 on the bottom because we have to have the bigger number on top. But if you do that, you have to add a negative in front of the integral. Okay, so we just negate it. Okay, so we're going to work on that, and then we're going to add it to the 4 over here. Okay, so if we go from 0 to 8, what is our area? So here is the negative, and now let's do the area from 0 to 8. Okay, so I'm going to get another color. So we know from 0 to 1, that's that area right here, we were told that that's equal to 2. They gave us that. Plus the area going from 1 to 4, that's this, they told us that the area was 6. Plus, I should actually do this with the highlighter so you can see these numbers through it. Here, so this one was 2, this one was 6. Okay, this piece over here is equal to 3, but remember, it's below the x-axis, so if it's below the x-axis, it's actually negative. So we're going to write negative 3. And then we have this up here, and this area is a whoops, I just said I'm going to use the highlighter, sorry, is a positive 7. Okay, so it's plus 7. So we get a negative. 2 plus 6 is 8. 8 minus 3 is 5. 5 plus 7 is 12. So we're going to get a negative 12. But don't forget we had this 4 over here. So we're going to do 4 minus 12, and we get negative 8. Okay, so that's f of 0 is negative 8. Okay, and we still need to do f of 6. I'm going to erase and make some room. So I cannot go from 0 to 6. So what I cannot do is this. I can't do an integral from 0 to 6 because I don't know where I was when I started. So we're going to do what we did before. We're going to have the 4 because that's where we are at 8. And then we're going to go from 8 to 6. Okay, we're starting at 8 because that's the only thing we know about. If we were told that f of 2 was equal to 4, then we would have started at 2. Okay, again, we can't have the bigger number on the bottom, so we're going to switch it, put the bigger number on top, but that means that we need to have a negative sign in front of our integral. Okay, so we have a negative, and now let's find the area going from 6 to 8. Well, to go from 6 to 8, it's right here. And that area is equal to 7. So we just get negative 7. So we have a negative 7 and a 4, and that gives us negative 3. So the question is saying, what is the absolute min? So you look at these three numbers, and hopefully you notice that the smallest number is negative 8. So you would write the absolute min is negative 8, and that is worth 1 point. And if you actually found these two things right here, that was worth 1 point as well. Okay, now we're up to C. So I'm going to erase. Okay, for part C, when is F concave down, both concave down and increasing? Okay, so let's deal with one thing at a time. So when is it concave down? Any function is concave down when the second derivative is negative or less than 0. Okay, so when is double prime less than 0? Well, f double prime is less than 0 when f prime is decreasing. Right? If f prime is decreasing, then on the next graph, which would be f double prime, it's going to be negative. So the question is, when is f prime decreasing? Well, this is the graph of f prime. So when is this decreasing? It's decreasing here from 0 to 1. I'll write it over here. And it's decreasing here from 3 to 5. And that's it. Okay, now we also, so we just found out when is it concave down, but we have to know when is f increasing. So let me erase this. Okay, so if f is increasing, then f prime would be positive. So when is f prime positive? So it's positive, and that means above the axes. So it's positive here from 0 all the way until it gets to 4. So I'm going to put that in a different color. So from 0 to 4. And then it's positive again here from 6 to 8. Okay, and so now the question is, what are the intervals that you'd have both these things? Okay. So how are we going to do that? We're just going to do one number at a time. So they both have 0, so we're going to have 0. They both have 1. This first one over here, there's no 2, so we're not going to include 2. They both have 3. Here's 3, and 3 is located in here. They both have 4. They both don't have 5. 5 is in this one, but 5 is not in this one. And then that's it, because we run out of these red ones. So if you did these two things, you got 1 point. Oh, and if you showed that this is when it's decreasing, you get 1 point. Okay, and finally we have part D. Let's clean this all up. Okay, for part D, it's introducing a new function called g of x. So g of x is f of x all cubed. Okay. Find the slope, meaning find the derivative of g. Okay. So I'll do it down here. I'm going to need some room. So g prime of x is going to be, this is going to be a chain rule. So bring down the 3, keep the inside. 3 minus 1 is 2, and then you need the derivative of the inside. So the derivative of the inside is just going to be f prime of x, whatever that is. Okay? So if you just did this thing right here, you just bought yourself 2 big points. That was worth a lot. Okay, so that's g prime. And the question is asking for what's happening when it's 3. Okay, so we're going to do, so I'm just going to substitute 3 into this thing over here. So I'm going to get 3 times f of 3 squared times f prime of 3. Okay, so this gives me 3 times, now what is f of 3? They gave you that. That's why they gave it to you. They never give you something you're not going to use. F of 3 is 5 halves, keep the squared. And now we need f prime of 3. So what is f prime of 3? Well, this is the graph of f prime, and when x is 3, what's the y value? 4. Okay, I'm going to make some room over here. This one is actually kind of fun. It's like a little puzzle. Okay, so we have 3 times 25 over 4 times 4. So these 4's cancel, and we get 3 times 25, which is 75, and that was worth 1 point, and that completes, whoops, sorry, that crashing noise, that completes the problem.